Hello, guys. Hello, Piotr. Hello, Rustam. Really
Hello.
nice to have you here on JPoint. So the first question before the talk actually that I have is it the right time to go to Java 16, to update to this, the latest version basically, or should we maybe wait a little bit more and update to Java 17? Piotr, what do you think?
I think if I am understanding your question correctly is should we wait for LTS or not?
Right.
And I prefer, when it comes to answering such questions, I prefer to quote Ron Pressler, one of the guys standing behind Project Loom. And he states, and I very like this statement, is that LTS is merely a business term. So it's nothing technical preventing us from updating our Java every 6 months. And in fact, maybe we should be trying doing this unless there's something like, I don't know, a framework or something really preventing us from doing this. But I think we shouldn't wait for LTS. And the previous release was also a great example of that with the new garbage collectors. Like we had Shenandoah, we had ZGC. This time we have records. And the more you wait, the more painful it will be to jump from 11 to 17, provided you're on 11 already, because that might not be the case.
Yeah,
that is true. I was just about to say the same kind of same in the same direction, because if you're going to stay on, I mean, if your policy for some whatever reason says that you should stay on LTS releases, it's kind of very nice to prepare for that. And do like jumps between LTSs can be a little bit too much. So it might be a very good idea to update as often as you can and just see and test and and try and see how it works.
Yeah, exactly. I would only maybe stay away from preview features if you're not like a library maintainer or something like this. So preview features are like, if you're okay and you can update your code, like the code you wrote every 6 months, in case there are some slight changes to preview features, that's okay. Also incubator modules. But apart from that, when it comes to regular features, there's nothing that should be preventing you from using them, maybe except this little illegal access being changed in Java 16, because it's no more permit, it's deny this time. So really, guys, it's time to either start using reflection or go for illegal access permit, which might not be the best one, or in a middle ground, go for add opens clauses parameters.
Yeah, right. Right. And maybe another small question before the talk. Do you think that records is actually the killer feature that will cause people to update to Java 16? Because, for example, in Java 8, it was lambdas, right? So lambdas was the reason why to update to Java 8. And my question is, will records be such reason to update to Java 16 or not?
Well, for me, they are really, really very nice, and especially if if you're capable of using final classes which are immutable, then they should be something that should drive you to for such an update. And if they are a killer feature, I mean, it depends. If you're using Kotlin or Scala, maybe not that much. If you're using value from Lombok, maybe there's something you can replace them. I mean, the values from Lombok with records. The thing is, records are gonna be or are quite painful for all these souls who are maintaining libraries or frameworks, because unlike other features we saw previously, like text blocks or switch expressions, there's something you cannot avoid. It's like with enums, right? You need to handle them, and that's it, because someone may come to you and say, persist it for me, pretty please.
Right. So I think there will be more details about that in the talk, right? So I guess let's start. Piotr, time to have this talk.
Okay, so thank you very much for this invitation. Thank you very much for this introduction, and thank you very much for this intro. I really loved it. I mean, these virtual paths that are connecting us today, because unfortunately we cannot meet each other in person. So welcome to this talk, Java Records for the Intrigued. My name is Piotr Przybył, and we are featuring my friend Rustam Mehmandarov, who will be answering or asking your questions on your behalf. So this is me. I am self-employed as remote freelance software gardener. This is my blog page, Software Gardener. I also work as a trainer from time to time. Меня сказали, что по-русски я называюсь Piotr Przybył. Где я живу? Я живу в Польше, недалеко от города Вроцлавia. И сегодня, как я сказал, я хочу вам показать эту новинку в Java 16, значит, рекорды. И, друзья, я хочу вам сказать, что этот доклад не для нас. Он не для меня, он не для Рустама, он не для команды JPoint, он просто для вас, чтобы вы могли задать вопросы, и мы хотим их отвечать. Или ответить. Sorry, my Russian is not that good. When it comes to Java, I'm with Java since version 1.3 in production. You see, even when I go on holiday, provided there's a holiday, Java is somewhere around close to me. And also, I would like to shortly introduce our expert, Rustam Mekmandarov, who's not only a Java champion, but also a Google Dev expert for cloud. Thank you very much, Rustam, for joining this talk. And folks, unlike me, Rustam speaks Russian fluently. So if you want to ask questions in Russian, no problem. We'll get them translated, and hopefully all of them will be answered. So who are you? I would like to ask you, because we kind of started this, right? In this small talk, in this short intro, I would like to write in the chat which version of Java you're currently at when it comes to production, whether it's 8, 11, somewhere in between, hopefully 15 or 16. Just let us know, because we would like to know you, our audience. And a little warning, a little safe harbor statement, caveat auditores, everyone can make mistakes, including us, so please don't do any bets, verify on your own. So records, what are records? Records are a standard feature now. They came as a preview feature to Java 14, but for Java 16, as Ivan said, released exactly 1 month ago, they are a standard feature. They are implementation of JEP 3.9.5 and a few JEPs before. And what are these? These are actually new kind of type declaration or new type of class. I like to think about them like remote cousins of enums. This is what they are like. So enums are objects once we have them, but they are like kind of a limited or restricted or have a special purpose. And exactly the same, of course, in a slightly different dimension, is when it comes to records. So record is a restricted form of a class. And every record you declare extends Java lang record, a new class, just like enums extend Java lang enum. Despite we cannot write this on our own. And a quote from the JEP: they are transparent carriers for immutable data. So I hope we'll come back to this immutable part, because this is what makes them different from JavaBeans, case classes in Scala, and also data classes in Kotlin, which all of them can be tricked to be or used as mutable ones, but we should rather try to use them as immutable data structures or data carriers, because they are about data, unlike, for example, streams, which are about actions. And this is a simple declaration of a record. So we can have like a new type indicator. So it's a record. And then we go, so instead of a class, we just put record, then we say the name of this class, of this record. In this case, it's going to be complex. And then we have so-called components, because this is the record's header. And we have components, so this very complex has two components, real part and imaginary part. And then it also needs to have a body in this very case. And hopefully in most of the cases we're going to see, this body is just empty, but it has to be there. So what records have? They have obviously a name, and this is what makes them different from for example, from tuples in Scala. They are named. They have record components, of course, and the list can be empty. Like in some cases, weird cases, you might not have any components, and this will still make a valid record. I don't know what for, but it's possible. And these records become or a source for generating private final fields. And they also have generated accessors. They have generated full canonical constructors, so we can call this constructor and create new instances of records. And they also have equals, hash code, and toString generated for us based on all these components / fields. And they also have a body, and in this body we can put some more methods. What records can do? I mean, they can, or you can redefine constructors like compact canonical, full canonical, or custom constructor. Don't worry if it like sounds like, I don't know, Chinese or Greek to you. Don't worry, we'll go into the code, into the demo, and we will see everything that in action. And they can also have own implementations of generated methods. Like if you decide to override, for example, toString or equals, you can do that. Despite, I mean, this might be a code smell in many cases. And these implementations, of course, should obey the invariants, the rules, or the contract, generally speaking. They can have extra methods, like if you really think this data you have in this record really needs an extra method to accompany it, you can add such a method. They can, of course, have static fields and static methods, and they can implement interfaces. So this is what records can do, and of course, they can also be generic. So let's go for the source code, and I have here, for example, a short demo for you. With a record, right? So we have a record. I mean, for time being, I can get rid of this and see this is exactly the same record. So of course we add the access and specify whether it's public by default. If the file is named the same, it should be public. Then we set record instead of a class, and here again the story goes. So this is it. And as you can see, I can add more methods. Like I can add this complex number to another complex number. I can subtract them. I can multiply them. And this means we can use them like this. Let me run this demo. Indexing. Okay, working. See, so we have this hello records coming from here. Then we have these two complex, and when we multiply them, this is the result, right? So the result comes from the toString method, and I've decided for this example to override this method because this is what I was told at university, right? When we had like algebra or higher mathematics. Okay, when I just comment this out, when we go this demo again, then you see the default toString method in action, which generates a result like this. So it's a name of the record, and then there's each component with the assigned value, something like this. And when you want to override this, as you can see, records are flexible enough, and there is no problem doing this. So this is a simple record in action. Okay, let's go for a project view because I have the basics like valid records examples for you. I mean, by the way, all the code is available online, so no worries. You can just go and clone it from GitHub and follow the demos we have. Okay, so what records can do? Let's go through the examples of valid things. As I told you, they can have no fields or no components. They can have just one component. They can be generic, you see? So we can have something that's serializable, something that is a number, and we can put it in here in the header. So this is what we're going to have. They can also have custom methods. You see, I have this print hello method, which prints us this hello plus something. Although I would say this method is kind of a code smell because it's not related to the data we keep inside, right? So I would say just because you can doesn't mean you should. And we can also have static members like static fields, static methods in here. We can also have fields which are mutable because all these components are turned into private final fields, which means they are immutable in a sense we cannot assign a new reference, a new object, a new value. However, if this very field or component is mutable, we can mute it, right? This is especially tricky when it comes to various collections and so on. So please be careful. And I would rather say, because records are meant to be immutable, rather avoid such things. But of course, if you need it, if you have really valid case or valid excuse, valid reason, then of course still it's possible. And as I have shown in the previous example, we can override the toString method, no problem about that. And sometimes we can override, when really needed, equals and hash code. Please keep in mind they need to obey their contracts and so on. so they should be implemented correctly. Nevertheless, it's still possible to implement them. We can also have custom accessors, because accessors get generated automatically. But let's say you want to have like a side effect or whatever, like log something, like in this very case, or any other actions. Then we can override such an accessor and throw whatever it's needed, and then return the thing. And now we go to the somewhat more specific things when it comes to records, which is the constructors. So we have so-called canonical constructors, and these are the constructors that like follow all the components. So here in the header, as you can see, I have 4 components, A, B, C, and D, and this is the canonical constructor, right? So I'm repeating the same stuff, and then, for example, for this very record, I want to make sure that component A is different than component B, and the same with C and D. And then I need to reassign this, and this is just to show you that, you know, this demo is running correctly. And one of the non-goals of records, because it's officially stated as non-goal, is the war on boilerplate, right? So as you can see, we have kind of a lot of boilerplate, because we have to repeat this list of parameters, right? We need to do these assignments. And what we actually needed for this very constructor is to assert these things, that these invariants are kept, right? And nothing else. Everything else is just like a ceremony. Like something can be avoided. And that's how, instead of full canonical constructor, we might be going for compact canonical constructor. And it's different in a way that it doesn't have this repeated list of arguments. See, it's like empty, and we don't have to do these reassignments. Like, this is done for us, so we don't have any list of arguments. See, it's not even empty. Right? It's basically missing. It's gone. It means it's a compact canonical constructor, and we can just add like the validation, invariants, assertions, whatever we call it, and that's pretty much it. So see, this is quite a difference from this to this. So whatever you need to add, like, or check if you don't have to throw an exception in a record, this is what you probably want to do, like go for a custom canonical constructor. And there's also another possibility, like we can add custom or non-canonical constructor that can create the instances of our records from something else that it's not related to the components. Because as you can see, I can have 2 int components in here, and I just want to store the length and a hash of a string. So I just pass the string, and then inside I call this canonical constructor, giving it the length of the string and the hash code of the string. By the way, I cannot name it hash code. It won't compile, because then the accessor would clash with the hash code method, of course. So that's why it is impossible. And these custom constructors, we'll get to that later as well, can have somewhat less visibility. As you can see, this record is package default, and this custom constructor can be private, and this is impossible for the canonical constructors. And of course, as I told you, they can implement interfaces. So see, this can implement interfaces. Record implements comparable. So we then just toss the compare to methods, which compares to instances of record. And records can also override, can use this override, right? So despite this, A is generated for us, and I just added here, added these 2 accessors for B and C for demonstrations. I can use this override, despite I'm not strictly speaking overriding anything. Okay, so if you have any questions so far, please let us know. Please ask your questions. Rustam will bring them for us online, so don't worry. In fact, do we need to answer any questions so far?
Yes, they're actually perfect timing, because we just received a question just a second before you said if there are questions. So the question is, I'm trying to translate it live. So why the accessors for records, they decided to use, not to kind of follow the specification of JavaBeans with get, set, and is, and things like that, because it kind of may break quite a few compatibility things with old libraries.
Exactly. And I think it's a perfect question. Just let me answer it a little bit later, just 2 or 3 slides later. I think I will have the answer for you. Okay. I think it's one of the most important, if not the most important question when it comes to records and like a kind of a backwards compatibility with the whole ecosystem and so on and so on. So what records, if that's
there is
okay
one more
with you?
question.
Yeah?
If you're done with the first one, it's just perfect timing with questions. They just keep on appearing.
Great.
All right. So the question is, this compact canonical constructor thing. Can you? It seems like you can use it only for inside a record.
I mean, I need to define it inside the record, right? But there is no problem. Let's see, we have this demo in here, this main method, calling it. So you can see, I should have it somewhere like custom accessor, and see, I have this custom compact canonical constructor in here, and I'm just calling it, right? I'm just calling it. It's the way to like be less verbose when declaring the constructor. And a constructor, like all of them, of course, need to be defined inside the class body, at least in Java. But then when I call them, they are no different from full canonical constructors. They behave exactly the same. As you can see, this is exactly the very same call.
Fantastic. And another question. Well, actually, 2 questions. One of them, I think that fits to ask right now. Does the record support inheritance?
That's what we're going to cover in the very next slide.
Okay, perfect. And before we do that, one a bit longer question. This talk is marked like #Lombok is dead, but the record is only part of Lombok. For example, a record feature doesn't allow to make a builder. And Kotlin passes this problem by using direct parameters name in constructing objects and default value. And generally, @builder for Kotlin is useless. Do you think that the record is not enough to remove Lombok from the code? And what is the next step to improve Java records that leads to real Lombok death?
Well, I think it's a perfect question to come back to the very end. It's just, let me answer it shortly right now in case we don't have time at the very end. It's just, first, I didn't put that hash code, and I don't think that Lombok is dead or is going to die. Like what we saw, records are meant to be immutable data carriers, like, right? So there are also other goodies with Lombok. It's just, with the latest release, if I'm not mistaken, it's 1820, something like this. Lombok decided like kind of stay away from records, because the previous versions, and I was like doing some sick experiments. You can find them on my blog post with Lombok, like trying to use Lombok annotations on records. For example, to get getters, like with this prefix. Now it's impossible. There is one trick to go for a builder in records. Maybe I can go for that. Let me just see. This is the Jab. Just let's go there quickly, since this is the answer. So see, something like this is impossible right now with the latest version of Lombok, 1820 in Java 16. But in case you really need to have a builder, we cannot just add this annotation builder on top of this class, because it will generate such a code using the Lombok, and this doesn't compile, doesn't work, and most of all, it doesn't create this ABC methods. However, if we add, this compact constructor and toss the builder annotation on top of it, then voila, something like this is possible. So see, we can still like make some connections between Lombok and records, because truly natively, so far at least, records don't have any builders. So if you'd like to have something like this, precisely something like this to be generated for you, then you can add this compact constructor and toss a builder annotation on top of it. So this is equivalent of such a code. However, I'm not sure if that's a good idea. generally speaking. So I don't think beans are going anywhere, at least for now, and I don't think that Lombok is going to die. It's just Lombok team decided to like step away from records, and I like respect this decision. I think it might be nice because records are supposed to be records, right? So maybe let me answer the question we had before. So what records can do? As you can see, they cannot extend classes or they cannot be extended. They are final, and the only class they extend in an implicit way is the Java lang record, and that's it. They can implement interfaces, but they cannot extend anything. They cannot have setters in a way that they will override the contents of the fields, right? In terms like replace this something in this private final field because it's a final field, so no setters. They cannot have any extra instance fields. They cannot have less visible canonical constructors. Custom constructors can be less visible than a class or the record itself. They cannot declare native methods. They cannot assign components in compact constructors. So for compact constructors are meant only for like validation. And if you like summarize all of these with just a few words, like too long didn't read, it means records can't do anything that puts the encapsulation of the state at risk. They try to make sure, I mean, the Java team, that records don't leak the data, so nothing can change the data, at least in a trivial way, and so on and so on. So we have another demo for that. And these are the limitations, right? So the limitations are like these. So again, there is a short main method for you to run if you really like to. So they cannot extend any classes, right? In fact, if you're still using Java utility, there might be more than just extending it. Also, they cannot be extended. See, so this is this record. I cannot extend it. It's not going to work. They cannot have any extra instance fields. They can have extra static fields, but not instance fields. So I cannot have something like super duper private, unlike, for example, case classes in Scala. And they cannot have anything like setters. Let's say we try to have something like a setter or setter-ish. So if accessors don't have this get method, let's try to get up this set prefix. It doesn't work like this. It's impossible. They cannot have any native methods because, as I told you, this would be risky that the state could leak away. And yeah, the canonical constructors, as you can see, this is a compact canonical constructor. It cannot be less visible, right? It's going to yell at us. By the way, for records in Java 16, I'm using the latest version of IntelliJ IDEA, so it's the 2021 with this fancy splash, let me put it that way. Okay, let's roll this back. And custom constructors, of course, they can be less visible. And also, compact constructors cannot reassign fields. This is something we can do in full constructors. And they need to have exactly the same list and names of the parameters in case you decide to overwrite the canonical constructor. See, so I'm not, because I was like having here capital A and R, I cannot just go for a lowercase, or I cannot swap the order of these parameters for this constructor. It has to match strictly what's inside the header. And of course, records cannot be abstract because they are final. We can say that they are final, but it's redundant. They are going to be final anyway, right? So this is what records can't do. Any more questions about what records can't do?
So there was one question, well, kind of related. So why the filed hash code in previous example, well, a few examples back, and its accessor didn't clash with auto-generated hash code method?
Well, it would clash, I would say, because see, I have this. It's named hash. That's why it's working. Whereas when I name it hash code,
exactly,
then it's not gonna work because it's illegal. I mean, this name is illegal, and I would say, well, let's try to do that. Okay, I mean, we shouldn't be doing demo because we should stick to this scenario. But let's go for equals. And surprisingly, equals works, right? Because it has maybe like a different signature, and of course, because then we'd have accessors, and equals has, I mean, there would be two. The name would be overloaded, right? Because we will have an accessor with gets int equals, and there will be equals method which returns boolean and takes another object as an argument, right? So that's why here we don't have this clash, but for a hash code we have this clash. That's why I named it hash. Okay, so records, my friends, are not JavaBeans.
Can I ask another question?
Yeah, sorry.
One more question. Sorry, I mean it's fantastic. There's questions just like popping up. So the question is, again, translating it live. So bear with me. Why did you leave the constructor in the records? Since they're immutable, why wouldn't you just leave it by default? Let me see. Why wouldn't you just allow use by default the pooling by value of method or something like that?
I'm not sure I'm getting this question.
Yeah, I'm having a little bit of trouble with that one as well. Would you mind to specify your question again?
I think it might be why it's even possible to override constructors in any way. And I think it's like, for example, let's say you have a rational number, right? You have a rational number and you have, I don't know how these are called in English, but something like let's say, a half, you can put it like 1 divided by 2, right? So we can have a rational number, and then we might want to check, for example, if this part is not 0, because it will create we cannot divide by 0, right? So there are cases when you need to validate your data before you construct a container for them, right? So that's why we would want to assert that this second component is not 0, for example. That's why records can have custom constructors, or just the allow overriding constructors, because you might want to do something like this. Or, for example, you get a collection and you want to make sure it's immutable. That's why then you, for example, go for let's say list.copyof to make sure it's an immutable collection, and so on and so on. So there are valid reasons to validate or wrap data we're receiving before they assign to actually the fields inside the record. I hope that answers at least what I understood from the.
Yeah, I asked for clarification, so we'll see if it appears. Until no more questions until now, so we'll see if the question will be asked again.
Great, folks, keep asking questions, because this session is about answering questions, right? It's about getting the knowledge. So on Monday you can go to your boss and say, "Boss, нам нужно использовать рекорды." So this talk is exactly for that, to show you what records are about and what they are not about. So records are not JavaBeans, because there was a hype last year when Java 14 was about to be released, and shortly after that, look, our records are so cool, they are JavaBeans only without setters. No, it's not true. They are not JavaBeans. They not follow this lousy specification or whatever we call it. They are just immutable data carriers, and that's it. Sometimes when you learn a new thing, you need to forget what you already know, right? And this is the time when you learn records, just forget about JavaBeans, okay? They are just POJOs with accessors, and they don't have getters. They don't have these methods with get, is, was, has been, or whatever prefix we have currently. And the way I like thinking about them, and I think it might come from Brian Getz himself, is that they are named tuples. So we have tuples, like in mathematics, we have tuples. In SQL, we have tuples, right? And they are just named tuples. And that's important that they are named and they have their own type. I have an entry on that on my blog if you want to go deeper with that. And sometimes require overriding equals and hash code. And I think these cases should be really, really rare. And if you really need to override equals and hash code, you should think first if you don't have any code smells, if your design is okay, if you're not abusing records. We should be using not abusing records, though sometimes it might be needed to override the equals, contrary to what people say this year, that you never have to override equals or write equals and hash code in records. So where they are very useful when it comes to nesting, because we can nest records and we can nest them just like static classes, and these local records are very handy for streams, reduce, and collectors as intermediate result type. So let me go for demo again, right? Because in code we trust. I could put anything to slides, yet it wouldn't be, might not be true. So for nesting, see, we have them nested just like we have static classes. So this is an enclosing class, and I have this nested record, and this is it. So I cannot access the field from the enclosing class. It's impossible because record behaves like a static class. See, something like this. This is not a static class. When I turn it into a static class, then I'll receive exactly the same error like I was having here. So as you can see, records behave as, or can be used as a nested class, meaning static. And what's really nice about this is I had this demo from Java 12 when we were introducing team collectors. And see, I have here this record. Let's comment this out, and then I need to go for a class like this. And this is the binish or a bin class, like a very minimum Java bean. See, so I have this full constructor. I need to override to string, and I'm not going for getters because I have public final fields, which kind of violates, the beans approach. Nevertheless, it's possible. And see, when I then go for this demo, let's run it. And in case you just want to T two operations, so you want to use this team collector like here, because we want to compute two things in one pass of a stream. We want to get the sum and the count of the elements, right? So we don't want to create two streams and have two separate passes, two separate loops. It's like having one loop doing two things at the same time. So we can go either for reduce method like this and then do two things, right? Or we can go for a team collector, which one like using counting collector, another summing long collector, and so on. And then we combine the results. And to have something like this, in order not to use such a nasty array like this, because it doesn't keep the type, we had to create such a bin or binish class, right? So this is what we needed, that many lines, and sorry, as you can see, it wasn't covering everything, like without setters and so on and so on. So instead, we can just now go for this record. We can just go, hey, I want a record, which is just a container for this count and for this sum, right? And what's even more important, see where it's declared. It's declared inside the main method, because it's not my intention to return it to the outer world, somewhere outside. I'm just perfectly happy to have this record defined for my local computation here, right? So this one line saves us that many lines, provided I'm okay with immutable container, and that's it. See, and when I just go for it, everything still compiles, everything still works. So this is, for example, where you might want to get rid of beans in favor of the records. And just as a short, I mean, this is strictly speaking beyond the scope of records themselves, but as a kind of byproduct in Java 16, we can also have now local interfaces and local enums. So not only records are local, and local in terms of being defined inside a method, right? So we could have anonymous classes like lambdas. Now we can also have also something like records and interfaces and classes defined locally. So this is something you can use from now on inside the scope of this main method. Okay, so this was about nesting records. Yeah, I just covered the local declarations. So not only records are can be local now from Java 16. Now reflection. And reflection, I really love, and I had here this tweet from Seryoja Yegorov that, about these stupid people using reflection or to overcome the limitations of the library. Sadly, someone removed the original retweeted video, so I cannot show it. It was about hitting this spoon. Nevertheless, if you have to go for reflection records, I mean, I'm okay where people like library maintainers are doing this. and if a regular developer needs to go for a reflection of a record, that something might be wrong somewhere. Nevertheless, we have two more methods on records now: isRecord and getRecords component. So this will tell you if it's a record, pretty much like isInum, and this will give you an array of records components. I mean, the type, the name, and so on and so on. So we can iterate and do reflection stuff or anything like this. So as you can see, because we don't have this get prefix, we now no need to worry like prefixing with is, was, and things were even worse for these big booleans like the objects, right? Because then some used is, then some used get, and it was like some poor libraries weren't handling that properly. Now with accessors and records, we don't have such problem. We know they're immutable, and we know they have exactly the same name as the component. So for a short demo on reflection, sorry. So we should have like a reflection. Yeah, so if you really go for a reflection, there is a demo for you. I'm not sure we're going to stay much longer with this. Basically, what this demo does is just I'm creating various objects, right? I mean, also bean and the record. And the most important thing is, let me find this corresponding line here. I'm using this describe bean properties of a record and of a bean. Like this is a proper bean with the getters, setters, and so on. And I'm using the bean info. So I'm calling this introspector get bean info to get me like the bean properties of a record. And that's why just tossing a record instead of a bean won't work, because when I'm calling this method on a record and I have this bean info for a record, then it has only one beanish, let me put it that way, property, which is get class method, right? And it doesn't see these other two, because I should have also other two, like reflections check. See, I have also integer and I have string, and they're not visible. Despite I have UID and string for the bean, which, as you can see, are visible in terms of this bean specification or bean convention, because it might be more convention actually than a specification. And see, I can see this get ID method as a like read method, and as a write method, like again a read method for this get string field, and write method which is set string field. And we don't see even these accessors being returned from bean property description, because records are not beans. Basically, they have accessors, they are immutable, they are like name tuples or immutable data carriers. So that's what's important. And when it comes to annotations, that's one thing. Annotations get propagated accordingly. Just a brief demo in case you were wondering how this might work. So something like this. Oh, plugin updates available. I don't want any updates now. Sorry. See, so I have this. These annotations for a record component. By the way, this is a new element type for since Java 16. Record component, also field method, parameter constructor, and annotation type, and so on and so on. And when I call it, put this as my record. The record is here. See, when I put it here, this fat annotation, which is about everything, it will get propagated, and then field annotation will get propagated only to a field, method only to an accessor method, parameter annotation will only get propagated to the constructor parameter, and so on and so on. So we may even run this briefly, because why not? Right, so as you can see, yeah, so these are the annotations, right? So annotations of the class itself, by the way, caviar, I use the name caviar because it's now in Polish, we don't say guinea pig, we say caviar. And this is this fun annotation on the class itself. But then when we have this component, it has the like component annotation, as you can see, and fat annotation, because fat annotation goes everywhere. Then for this component field, we have this field annotation. Then for equals, we don't have anything. Also for string and hash code. But then for this method, this accessor, we have this method annotation, and so on and so on. So we can use annotations on records as well. pretty much like like in this demo, this example, you just need to remember they get propagated accordingly. Do we have any more questions, Rustam?
Yes, we do. So we got a clarification on the question we got earlier. That is about the pooling thing. So pooling in meaning like something that you would typically have with database collections and everything. Like so when you have immutable objects that can be reused. And the question is why. Why don't we have the out-of-the-box pooling functionality for records since they're immutable as well?
They are immutable, that's true, but we need to specify what kind of immutability that is. They are immutable in a shallow way. They are not deeply immutable like in C++ when you could throw a const, for example, on a field. Right? So they are immutable on a shallow level, but for example, you might have a list or a mutable integer or whatever, and then it mutates inside. So of course, this is most probably the way we shouldn't be using them, but still, it's still possible, at least at technical level, language specification, and so on. Second thing, records are records. They are immutable data carriers, but please do not confuse them with value-based objects, because only value-based objects from Project Valhalla, by the way, in Java 16, we start to receive warnings about misused value-based objects and classes. Value-based objects are about like losing identity of an object, because when you're going to use like a number, let's say 42, then 42 is 42, right? You don't care about the instance, and this is why for these classes like long integer we have this pool, and when you call value of, then it gets it from this predefined array or whatever that is, instead of creating new instance. But that's for value-based classes, not for records. I'm not trying also to say that records in the future won't be able to be value-based classes, but these are two different orthogonal concepts, right? So please try to not mix them, basically.
All right.
Any more questions?
More questions. So, okay, now I'm translating again. So it's understandable that the records are named enums, enumerators. But in this local context, as you are showing, we could create a unnamed record, or can we? And if not, why not?
We cannot do that because I especially for that put that in bold, because they are named tuples, and so they need to have name and type, and this is what makes them different from kind of anonymous tuples like we have in Scala, for example. And I'm just looking for an answer for you, lady or sir. Because I had something like here, I think, about this. I mean, there should be, or this is not this entry. There should be another entry for that. When I tried, yeah, this is exactly this entry. Right? So we see when we have something like this, and this is anonymous tuple from SQL. And when you have something like this, then you can go for union, right? And see, I'm mixing packages with cars. And despite this field has exactly the same type as this field, and this like this, right? I'm mixing peaches with apples, packages with cars, just because they happen to be anonymous tuple of two integers, right? And this is exactly why records aren't anonymous, or we can't have anonymous records or tuples. They need to have their name and types, because then we have complex and package size, and we cannot mix them. I mean, you can mix them if you have a common interface, or you just have a collection of objects, right? But when you have a set of complex numbers, you can't go for adding the package size, because there's something different. Whereas for anonymous tuples, as shown here with this SQL union example, that is still possible. So Java tries to keep us as safe as possible, my friends, and I would say it's a good thing. Like in Scala, we have two concepts, case classes and tuples. Records are somewhere in between, right? Any more questions?
No, none so far. So let's continue, and then I'll jump in when they appear.
Great. So let's go for serialization of records now. So one thing I also love about records is that they are reconstructed using the constructor, right? Because now constructor, I mean, in terms of records, is used not only for creating new objects, but also reconstructing objects when they are deserialized. I mean, this serialization in terms of, Java serializable and so on and so on. So maybe libraries and frameworks need to adapt to that. And I am going to show you a demo for that again. We should have a demo for this. Let me, whoa, that went too far, sorry. I mean, this presentation mode is giving me some hard times. Okay, so I have this serialization. So we have this serialization record check, which is a record, as you can see. And we also have a bean, which is, as you can see, just a class. So we have serialization here. And when we are going to serialize and deserialize them, one thing I'd like to bring to your attention is that we have this statement in the constructor, right? Just to track where this constructor is called instead of using like breakpoints, okay? And this is it. This is just it. So let's run this demo. And let's examine the results. And what I'm doing here is, see, I'm checking serialization on a record and on a bean. And inside, you see we serialize this object that we were given here to a byte array. Then we examine bytes, and then we deserialize it, right? So when we do it for record, you see this creating record from the constructor. So this is this message, we're creating the record, right? And then we serialize this object. These are the bytes, right? And then when we are deserializing, you see this message from the constructor printed again. And this is something that doesn't happen for ordinary bean, because you see deserializing object and deserialize, and in between we don't see this message from the constructor. So that's different, right? So the constructors finally use the constructor for deserializing. And also, if you're curious, really curious, I don't think you have noticed that so far, it's just these bytes are somewhat different. I mean, the format is slightly different, so we need to take care of this. Like 95 is still okay here, but you can see now I have 70 here, and this is something like 101. So to a certain point, these bytes are the same, and then the format changes. So instead, in case you're sending your beans or records over the wire, please make sure that someone may send you record and you know how to deserialize it, right? And another thing that might be even more interesting when it comes to this serializing, deserializing, and stuff is, I call it JSONification, right? Because we may also serialize object to these other formats like XML, JSON, and whatnot. So here I'm going to use JSON, and see, I'm going to write, I have this bean, and I'm going to serialize and deserialize this bean. Let's see if it's going to work. Oh, sorry, not wrong project, wrong class. Let me run it for this one. Yeah. And did it work? Yeah, it did work. So we were able to serialize and deserialize this bean using JSON. And how did it work? We tried to do a bean which kind of mimics our record. Then we have to do two things. We have to go either for constructor properties or JSON creator, and then list JSON properties here, or just go for constructor properties. Or we can, and also to serialize it, we have to toss a JSON property, because if we don't do this and we don't have like a bean which has getters, setters, and all these constructors as needed, then most probably, exactly, it's going to blow. It's not going to work. It says it has no properties to be serialized and so on. See, no properties discovered. So when we have these immutable beans, we have to tell Jackson to handle them accordingly, or we can try to go for the same approach for records. and let's see how records are serialized and deserialized when it comes to Jackson. Again, it doesn't work because no serializer found. Yeah, right, and so on. So it fails because it thinks it's an empty bin, so a bin without any properties. So again, we can go for a custom serializer and deserializer, but maybe we can just handle it with a few annotations. Apparently we can. So as I have shown you how they are propagated, these annotations. So once we do something like this, we just tell this component is something to be serialized and deserialized. Then you see it's working. We have created this record, and then we have just deserialized it back from JSON. However, what if I told you that I don't like this code? And this is another reason why maybe, folks, we should be keeping our libraries up to date, because let me go for a POM file. And in POM, I'm not going to enable Lombok, don't worry. Don't worry, I'm going to bump my Jackson to be at least 212. And we can go for 212.2 or even newer versions if there are such versions. And now let me go back to this record. See, I'm not using any annotations here. Like I can even delete it, if you will, right? Something like this. And let's run this demo again. And what do we see? Come on, indexing, checking, parsing, writing, finished. And boom. Let's check the result. Haha. It got serialized and deserialized just as a bin. And see, it's immutable, and we didn't have to add any clumsy annotations here or create any custom serializers. Why? Because Jackson from version 2.12 recognizes records. So the maintainers of Jackson took the time when records were a preview feature, they implemented support for this, and so on and so on. So this might be the case. When you try to use records, please make sure that your library actually supports them already. I mean, there are still some corner cases where they're not supported, especially where the library is like really trying to use mutable bins, and it's unable to use final classes, like final bins without certers. Odds are, if this library is able to use final bins without certers, records are more or less like okay to go, right? And nevertheless, for the Jackson, they added special handling for records. So as you can see, I have just record, and this is exactly the purpose of record, right? I have a record, and it means like instead of record, I could write, or you should see in your brain, we should all see that like this is immutable data structure, right? Record, like I don't know, struct in C++ and so on. So then all the libraries know, aha, this is the data, so I know how to handle it because of this class is record, because these get record components, and so on and so on. Everyone recognizes you want them to handle records, you want just them to handle data, and they behave accordingly, just like Jackson in this very case. Rustam, what about questions?
We do have some questions. So one of the questions from about something that you talked a little bit earlier. So it's about let me find the question. So the record looks like a possible thing for database model or DTO for API. Should we use it for this problem or not? And if yes, don't you think that restriction of inheritance leads to code duplication problem in the main model? If we have some general fields on model and several specific, we can use inheritance in our class model, but not in record. So yeah, long question. If you want me to rephrase it, just let me know.
I think I got the idea, because this is one of the things that people think we should be using records for. See, I have this simple. Let's narrow this for JPA first. I mean, one thing is that records are records. They are for immutable data structures, and data structures are more like about composition, not inheritance, right? So we have this JPA here, you see JavaX persistence, and I can have immutable entity, but still this class cannot be final. because when it's final, it's not going to work. I mean, let's see. It didn't show it instantly here. I would need to like recompile something. Anyway, I need to have this this empty constructor, and I need to have maybe this constructor, and then this would need to be immutable, right? And I cannot use a record for an entity because records are implicitly final, and they cannot. If you have any components here, they don't have any. You cannot have an empty constructor. I mean, constructor without any fields like this default constructor, right? So this is not going to work. We cannot use them as entities, though we can use them as DTOs, and they are perfect for DTOs, like receiving requests, sending response, and just passing the data here and there in every direction. However, I mean, this can be changed perhaps. Like, as you can see, I have a record, which is an entity, right? But please, like, notice one thing. This entity is not Hibernate or JPA entity. It's a Morphia entity. So Morphia, it's an ORM for MongoDB, and it perfectly handles like final immutable classes. From Morphia's point of view, these are valid entities too. Like, for example, I mean, like log events or something like this. You just log them, and then you don't modify them anytime. Right? So for Morphia, these entities are okay. For JPA, these are not okay because, as we know, JPA or Hibernate needs to like create proxy classes inheriting from these entities and so on and so on. That's why it's not going to work for entities. It will work for DTOs, and this is what they are meant for. And if I'm sorry that they don't have inheritance for such things, actually I'm not, because records are meant to be immutable, and when you inherit from someone, it means that you would need to, give your control over this immutability away, basically. So maybe there would be a way like inheriting a record from a record technically, but if that's not too much complicated, I'm not so sure. Maybe we shouldn't have anything like this, right?
I have a related question to that. So are there any limitations for using records as a data transport object?
I don't think so. I mean, as long as you're comfortable that you have to create it at once, so you cannot mutate fields. I mean, you have still build a part as an option. Then it's okay, right? So this is it. So they are perfect example for DTOs, for value objects, something like this. So you create your data, you make it immutable. And actually, I mean, I like this approach that because many people are afraid that immutability or lack of mutability is a serious problem. Actually, it's not. When you create like a server side, like a backend application, actually the only mutable state you have is in your database. Right, so there is, at least you have some. I mean, there are some corner cases like, I don't know, cache, which is mutable, and so on and so on. But really, like going for functional style is not that much big of a deal. And then think of the benefits of immutability, right? So you can use the same instances. You don't need to worry about leaking classes. I mean, leaking fields and so on and so on. About this deep copy and things like that. Like immutability is a compromise. And some say that mutability is basically an optimization towards lesser usage of memory. And that's pretty much it. And then there's another quote about, optimization, that a lot of them are, especially these prematures, are root of all evil, right? So maybe mutability is just optimization towards, a smaller usage of memory, and maybe it's not that much needed. Try thinking of it that way, because I think that first, when you create a class, it should be final, and all fields should be final, right? Yep. And this is exactly what record does. And there are like JP entities, some cases when you need to have mutable classes. Fine, that's okay, and like we keep that in this enclosure. Why not? It's just for DTOs, for records, for, I don't know. Let's say you call a web service and you receive a JSON. Then do you mutate this JSON? Like, or the representation of the JSON? I don't think so. So exactly, this is what records are for. They are perfect for this.
One more quick question. Do records have static inheritance initializers?
They actually, I don't know that, and I'm not quite sure. I mean, we could go for this, like static. Sorry, hello.
It's always
apparently they do. It's just yeah, and of course they can have static fields, so it's like static string field, right? And I could initialize this field like field equals hello. Sorry, I don't have like a Russian key layout. I cannot say привет. But we can have them. It's just, aren't we abusing record in this? You know, we're using something like this. I mean, there might be some cases, some valid cases when this is truly needed and like the best way to address an issue. I'm not trying to say like you should never use them. It's just, for me, it would be a code smell that someone, by using this inside this, maybe doesn't know what this is all about. Okay, so if there are no more questions, I'll just go for this. Yeah, copy. So records don't have any copy or with method, right? There are a few limitations. For example, in Java, we don't have default values. We don't have named parameters. That's why we don't have this copy value. We are supposed basically to call the constructors, right? So when you have one object, one record, of course, record is an object. When you have one record, one instance, and you want to create a copy, you just use every accessor again and again using the constructor, and this is how you end up with a copy in case you really need a copy, because if you have immutable things, why would you need a copy, right? So it's always the same. And that's why it's important for all these accessors, equals, and hash code to obey their contracts. So really, friends, read the freaking manuals and make sure you, in case you really need to override these, that you obey the contracts. And I don't know, maybe in future, because of this, let me show you, I should have another demo, just short demo. If I should increase the font, let me know. I decided to go for these other features, because records are going to use other features as well, and they play really well with these other features. So as you can see, we have these sealed classes, right? So I have the sealed classes of a bird. Each bird has a color, and then I have two records extending this sealed class, and because they are final, I don't have to use them, like redeclare that they are sealing this. So I have a duck. Утка, конечно, это тоже птица. As you can see, it has a color, it can swim and it can fly. Here is a chicken, курица это тоже птица. И tutaj здесь мы можем увидеть, as you can see, that we can describe both these birds. And see, so we were using sealing here, and now we're using pattern matching in here. I mean, this pattern matching with instance of C. I'm not just calling duck, but also calling that duck. And we have this, so we have a duck and we have a chicken. See, so this is a brownish gold chicken. So currently, and this is one of the advantages of switching to records in favor of sticking to JavaBeans, because when we will see like full-fledged pattern matching with object deconstructors, I think records will receive them right away, like, you know, by default, right? So we'll be able to get, for example, something like duck, and then color, speed 1, speed 2, and so on. So we have these components inside right away. That's why I would say, if you can jump to Java, so why doesn't it work? Maybe it requires like a recompilation or something. If you can go for Java 16, then go for records, because in the future we will benefit for more, because as you can see, records work really, really nicely with sealing, which is still a preview, but it's supposed to be a thing with Java 17, and it also works with pattern matching, even if we have only pattern matching with instance of. So this is exactly what I told you. And in the future they will support pattern matching with deconstruction. So this will make Java more and more like in functional style. more on records on my blog. If you're interested, I have several entries on records. And folks, always provide your feedback for all the speakers on all the events, because we need to hear from you to know what you think about it, how should we improve our presentations. So this is a small anonymous poll. Please follow the link. In case this poll is anonymous. I don't know your names, your emails, or whatever. So you can say what was good, you can say what was bad. I will share the results with the organizers, as I always do. And that would be it for today. Большое спасибо, especially for all these questions. We received tons of questions. I see this, it's over like 120 entries in the chat. We'll get to that later. And the slides are here for you. Thank you very much. Back to the studio. Ivan.
Yeah. Piotr, thank you very much for such a great talk. And Rustam, thank you for questions that you've asked from the chat. It was really great. And I think for many people now it's much more obvious that they should update to Java 16 and that they should use records, and why should they use it. And also, Piotr, thank you very much for your great Russian speech in the very beginning and the very end of the talk. It was just wonderful and nice. So thanks a lot just for that. You can continue discussion in special discussion zone. I think there are some more questions, and you will continue discuss them there. So thank you very much again, and see you there in discussion zone.
Thank you very much.
See you.